we're going to write a small summary on the bottom of the notes page that I gave you yesterday. If you want the rest of the note packet, small reminder, go print it. I printed the first page for you so you could see what it was like versus having to write those things on your own, like all the problems and everything. But I'm not going to provide the rest of the note packet for you, okay? Unless you come in a tutorial, you're unable to print, and you need me to print something for you, then I'll do it there, okay? So we're going to go through the transformations. So you guys started by looking at A, and this is review from Algebra 2. So we're going to talk about A, H, and K, and then we'll come back to the B value, because that's kind of the new idea that we're looking at. So what does A control about your graph? What kind of transformations can it cause? So remember, your transformations can be reflections, translations, which is like shifting things, okay, like sliding them over or up and down. And then, so reflections, translations, or stretching and compressing, okay? So what does A affect? Okay, so one thing it can do is it can stretch or compress your graph, right? So you guys saw the square root function. When you change the A value, it got kind of like higher arching, or it got really flat and almost looked like a straight line. So the number that A was affected that. So if your A value was bigger than 1, and notice I put absolute value bars around it, that's not to like be super scary or whatever. It's just saying I don't care if it's positive or negative, so I'm just talking about like the number part. Like if it was a 2, whether it's a -2 or a +2, the 2 part, because 2 is bigger than 1, is causing the graph to be like double the height that it was previously, okay? So when the A value is bigger than 1, it's causing a vertical change, and specifically it's stretching the graph out from the x-axis, okay? And so that's something that you guys have studied from Algebra 2, okay? All of these are. When you made A really close to 1, it took it and it kind of made it almost like a straight line. Like it almost looks like it didn't have any curve to it. Okay, so when A was less than 1, it was taking all the points and pushing them almost flat closer and closer to the vertex. So again, it's vertical, but it's compressing it. Okay, it's pushing it closer together. So this would be a vertical compression. What else could A make happen? Besides making the graph arch up more or almost look straight, it also caused something else. What else happened when you slid the A values around? Deflection. Yeah, it caused it to flip over, right? Originally the graph kind of looked like this, but when you slid the slider over so that the A value was negative, all of this, you saw the graph kind of looked like this, okay? The A is affecting the Y values. Okay, when you plot y coordinates on the graph, you go up if it's positive. But once you switch that and make it negative, it takes that +2 and flips it to a -2. So it changes the y values and it flips your graph over the x-axis. So if A is negative, so the way we would say that is if A is less than 0, if you want to just write negative next to that, that's fine because this is understanding. It's over the x-axis. So it's kind of weird. The negative is changing the y values from positive to negative, but when you change y's from positive to negative, you flip stuff over the x-axis. Okay? All right, what does H do? So what does the H value do? You guys got to see it on there. You took Algebra 2. Okay, so Logan's right. He's going like this, right? Our H value causes translations left and right. So H is going to be completely in charge of sliding our graph left. But what do we have to be careful about when we're using the H value? Like when we look at the equation, H has some extra like layers to it. We don't just get to see the number in the equation. If the equation says x plus 3, what is the H value? -3. Remember your guys' formula from Algebra 2. Everything is supposed to come in this little x minus h package. That means if it says x minus 2, the minus is from the formula and the h is actually a +2. If it says x plus 2, then that's really like having x minus -2, and that's when the h is negative. So remember that the h value isn't as like straightforward. You can't just see a +3 in the equation and actually use +3. We have to think a little more about it. Okay? What kind of transformations do the k values cause? Another translation, but instead of left or right, because it's like outside of the function, it's changing the shifting vertically, okay? So the k value, when it's added on to the end of the function, is causing a translation up or down for the graph. Okay? So the b value was the new kind of content that was in there for you guys. So the b value was inside your radical, right? So it's affecting the x's. So it's about horizontal stuff, okay? If it's changing something horizontal, we want to establish what was it changing exactly. So when you guys slid the b values, what did you see happen to the graph? Did you see it reflect? Did you see it translate? Did you see it stretch or compress? Multiple of these, none of these. If you're not sure, go to the b value slide on your thing, slide the graph. What did you guys see change? Okay, so it can flip different ways. So one thing that changed was kind of like the a value. The graph was originally pointing this way, but when we changed the b this way, so the b is affecting the x's. So when we change x's that used to be positive and we change them to negative x's, it flips our graph over the y-axis. So if b is negative, we still have a reflection. So negatives are always causing reflections. But this time, it's over the y-axis. Changing the x's, and when you change the x's from positive to negative, you flip over the y-axis of the graph. Okay? What else did b cause to change about the graph? Was it changing the starting point? Did it ever shift over from the 0, 0? No. Okay? But you should have seen the curve change a lot like it did with a. So it was still experiencing stretches and compressions. The difference is that b is in with x, so rather than stretching it and compressing it this way like you did in Algebra 2, when that b value, that number is multiplying and it's inside of the radical, it's causing like the horizontal parts to stretch or compress, okay? So it's still a stretch or compression, it's just measuring horizontally instead of vertically, and it works a little bit weird. And we're going to say it here, but we're going to practice with it a lot later. So just like with A, it breaks up into two categories, okay? But here's the thing. When you guys see an equation that has this in it, okay? Oh, sorry. That doesn't look right. Okay. It has a 2 inside the equation as the B. And that 2 means something, but it doesn't mean the same thing that we measure when we plot points on the graph. So that 2 means that the x values are going to reach the new y values kind of twice as fast as they used to. But our graph doesn't measure how fast it's going. It kind of measures how long it takes. So I want you guys to think about it like this. Let's say that you started doing something twice as fast as you used to do it. How long is it now going to take you to do that task? If you can do it twice as fast, it will take you half as long. Does that compute with everybody? Okay, if I can do it 4 times as fast, say I change that to a 4, how long will it take me to do the task? A fourth of the time than it used to, right? So as this number gets bigger, the amount of time that it takes you, or the amount that we're measuring on our graph, actually gets smaller. So it's kind of backwards of what we used to think. When the b value is getting bigger, when it's bigger than 1, it's actually taking less time to complete the task or get to the next value. So it's actually a horizontal compression. Okay? Whereas if you put something inside the equation that's smaller than 1, like let's say I put a 1/4, that means I'm going slower. Like x is taking a fourth, okay, or going a fourth of the speed that it used to go. If I'm going a fourth of the speed that I used to go, how long is it going to take me to complete the task that I'm doing? Think about it. If you take a test and you take it a fourth of the speed as you took it last time, how much longer is it going to take you to complete that test? 4 times as long, right? Because you're working at a fourth of the speed as you used to. So when the number in here is small, what we're actually measuring on the graph gets really large. So this becomes a horizontal stretch. And then I just want you guys to make one note next to B, and we're going to refer to this when we're actually doing the graphing. I would write down to use the reciprocal. The reason I would write that down is because about the equation says 1/4, but what did we actually say that's meaning on our graph? 4, and that's a stretch, okay? You guys don't have to do any homework specifically with this, but we're going to refer back to this every week because every time we go graph a function, next week quadratics and cubics, the next week square roots and cube roots, we're going to refer back to all those transformations every single time, okay?